Hey, Algebra 2 students, we're going to talk about exponential functions and the application of them, so real-life situations. So there's the exponential growth formula, and then there's the exponential decay formula. And so what these mean is a of t, so that is like your y. Little a is where you start. The r is going to be your rate, so that's going to be your percent or decimal. And then t is going to be your time. So it could be in years, hours, anything like that. So here's our first example when we're using these. First of all, you need to decide whether or not you're going to, is your data or your information, is it growing or decaying? So that's how you decide, is it going up or going down? That's how you'll decide if it's growth or decay. So with this, the first U.S. Census was conducted in 1790. At the time, the population was 3,929,214. Since then, the U.S. population has grown by approximately 2.03% annually. So it looks like we're looking at years here. Our rate is 2.30%. So that means our rate is going to be 0.0203. We have to change this to a decimal, so we move our decimal to the left 2 spots. So write an equation to model this situation. So it could be a of t. If you want to use y, that's fine too. Equals our starting population is this number right here. And then it will be our decimal right here. So since it's growing, we're going to use this here. And so that's going to be 1.0203. All I did was add this to 1, and then t is our variable because the years is what's changing. So we're going to estimate the population in 1900 and today. So let's start with 1900. Since this is starting in 1790, for 1900, okay, t is going to equal, sorry, my dog needed to be let out. T is going to equal 110. Okay, so all you would do is plug that in, and I don't have a graphing calculator here, so I just use Google. I just Googled the calculator, and this works out fine. This is your exponent button right here. So you can take, what you're going to do is you're going to take, here, I'll erase that. So you're going to plug in 110. So what you're going to do is take t and plug in 110 for that. So on your calculator, order of operations first, do the exponents, then multiply by 3,929,214. Go ahead and pause the video, and I'll let you do that. And this is the number that I got. And so you'll notice you'll probably get some decimals, but since we're talking about people, we'll round down. Okay, now go ahead and do the next one, which is 2020. So in 2020, that's this year, our t would be 230. And because this, again, represents 0, okay, 1790 represents 0. So go ahead and plug it into your calculator. And then this time you're going to take it to 230. And what do we end up getting? Go ahead and pause the video and try it. So here, I was getting my commas wrong here. This is what I got. And then you can also label this as people. So when you were doing these word problems, we have to have people in there as well. Okay? All right, let's do another example. So here, a cup of green tea contains 35 milligrams of caffeine the average teen can eliminate approximately 12.5% of caffeine from their system per hour. So we're going to create that model. So this one is eliminating, so that's DK. So again, you can use A of T, or you could just use Y as well if you would like. But our starting value is 35. And then 1 minus, if we take 1 minus, this is 0.125 as a decimal. That's your R. And then we're going to have 1 minus 0.125. That's going to be 0.875. And T is our variable, which represents hours. So after 3 hours and then 5 hours. So we're going to go ahead and evaluate that. So it looks like we're going to have for this one y equals 35 times 0.875 to the third. And for this one we'll have y equals 35 times 0.875 to the fifth. So go ahead and compute those and see what you get. Go ahead and pause the video. Okay, this is what I got. After 3 hours, it's 23.44 milligrams, and then after 5 hours, it's 17.95 milligrams. All right, let's do one more example. Compound interest. So this is a new formula when you have compound interest. Go ahead and pause the video and write that formula down, and this is what each one of those letters represent in this formula right here. So go ahead and write that down as well. So it looks like our R is going to be 0.042. 2,500, that's going to be our P because that's our starting amount. T is going to be how many years. N represents the number of compoundings per year. So since this is an annual interest rate, okay, and it's compounded monthly, your N is going to be 12. So our formula then is going to be A equals 2,500, and then it's going to be 1 plus 0.042 over 12 to the 12t, because we just plugged it in there. And you can simplify that decimal right now. So I looked that up, and we can go ahead and simplify that decimal. So it looks like it is going to be 2,500 and then 1.0035 12t. So again, we're going to go ahead and calculate after 3 years and then after 25 years. So go ahead and pause the video and plug that in for each one and see what you come up with. I'm going to pause as well, and then we'll compare our work. Okay, so for after 3 years, I get $2,835.08. And then after 25 years, we get $7,131.04. So this is just a good way to see how when we invest our money, how much we can make back, like in CDs or using just putting in a savings account, stuff like that. So, alrighty, that's all that I have. If you have any questions, please contact your teacher. And yeah, we'll see you later.